Welcome and study with Tanzania Institute of Education.
Welcome my students to math class. My name is Mr. Ami Hajivuai, and today's topic is trigonometry from 2. So you are welcome. Trigonometry comes from is a Greek word which comes from the two words, which is trigonon and metron. Trigonon means triangles, and the metron means measure. So trigonometry means the measure of the triangle. And trigonometry, from here we come up with the definitions of trigonometry, which is the study or the branch of mathematics which studies the size or the relationship between sides and angles of a triangle. Is a branch of mathematics which studied the relationship between sides and angles of a triangle. That is the definition. So trigonometry is a branch of mathematics which studies the relationship between sides and angles of a triangle. So this topic is very, very important for our daily life. It helps to find the height of a tower or tall tree, but also it helps to calculate the height of the waves and also the tides in a sea. But also the topic is very useful because it supports other topics in mathematics and also other subjects in science, particularly physics and the chemistry. So this topic is very useful for our daily life. So you are welcome. So today's concern is trigonometric ratio. Okay, because one of the applications is to measure the height of the trees. Let us say, suppose we have a tree. This is a tree. And my friend Juma, let us say this is Juma, is looking to find the height of the tree. So Juma has 3 alternatives to find the height of the trees. Alternative 1, to cut down the trees and to measure the length of the tree. And also he can climb that tree up to the top with a rope and then to measure the length of the rope. And the alternative 3 is to make a scale drawing by measuring the length from the base to the top and also the angles makes the ground to the top of the trees. The previous 2 methods are not safe because it's not allowed to cut the trees, and sometimes to climb the trees is not safe and such. So we opted the third ways or approach by taking the scale drawing. And from here now we come up with the length. This is the h, which represents the height of the tree. And this is the horizontal levels. Sometimes it can be a shadow of the trees. And these angles makes the ground to the top, like this. And the tree is perpendicular to the base, to the ground. So it makes the right angles. And now the triangle here is formed. This triangle is called the right angled triangle. And why so? Because right angle triangle is a triangle in which one of the angle is 90 degrees. So we can call it B, which represents the base, or whatever you like. You can call it even C. And here is A, and this is C. So we have a triangles A, B, C. And it makes a certain angles, unknown angle, or call it angle X. This is angle X. So the triangles have three sides as usual, but the longest side, the side AC, is called the hypotenuse. This is called the hypotenuse. This is the longest side. And the side AB, which is adjacent to angle X, is called the adjacent side. This is adjacent side. And the side CB or BC, which is opposite to angle X, is called the opposite side. So again, the triangles have sides. One of the sides is hypotenuse, which is the longest side. The side which is adjacent to angle X is called the adjacent side. And the side which is opposite to angle X is called the opposite side. Again, by taking the triangle, the right angle triangles, now we can extend this. We have a right angle triangle, the same one, but now we can extend this so as to have more triangles. And that three of whatever you like. Now we have about three triangles which are similar. The first triangle is A, B, C. The first one. The second is A, D, E. And the last one is A, F, and G. So these are three triangles which are similar. And now here we have to think or to remember the concept of similarity. And the concept of similarity says that if two triangles are similar, if two or more triangles are similar, the ratio of corresponding sides are equal. The ratio of corresponding sides are equal, as well as corresponding angles are equals. But today we are not consider the angles of the triangles. We are looking for the ratio of corresponding sides. So from here, we have about three ways to have ratios for this triangle. The ratio number one is if we consider ABC over AB. This sides divided by this. It's the same as taking DE over AD. It's also the same as taking FG over AF. Again, BC over AB is the same as DE over AD. The same as taking the last one, FG over AF. And these ratios is equal to, let us say, T, where T is a ratio, is a constant ratio. So T is a constant ratio, and it is called the tangent to angle A. It is called the tangent to angle A. And normally is written as tan A. Normal is written as what? And the normal is written as tan A. is written as tan A. So this is ratio number 1. Another ratio is, we call it ratio 2, by taking the length BC over the length AC. It's the same as taking DE over AE, the same as FG over AG. So it means also we have BC over AC is the same as DE over AE, the same as FG over AG. And this ratio is so-called the S, where S is a constant ratio, where S is a constant ratio, and normally is written as a sine A. It is a sine of angle A. We call it sine A. That is the ratio number 2. Okay? Now, the last one, ratio 3, or similarly, another ratio is BC over AB. Sorry, AB over AC. AB over AC is the same as we have AB over AC, the same as AD over AE, the same as AF over AG. Okay? So AB over AC, the same as AD over AE, is the same as taking the ratio AF over AG. And this is called the C, where C is a constant ratio called the cosine of the angle A, and the symbol is called the cosine A. Where C is a constant ratio called the cos A. Cos A is a cosine of the angle A. So now we have about the 3 ratios. So the 3 ratios of S, which stand for sine of the angle A, C stand for cosine of angle A, and the T stand for tangent of the angle A. It's called the trigonometrical ratios. Okay, so these are called the trigonometrical ratio. It means the ratios can be defined in the above ratios. Well defined as, so this is our right angle triangles, and it must be right angle to the certain point. Let's call it B, and this is A, and this is C. And then still we have our angle X, which looks to the sides AB, BC. And we said before, this is hypotenuse, the longest side, and this one is opposite side, which is opposite to angle X, and this is adjacent. So by considering our 3 ratios, the first ratio is the tangent, which is the ratio of opposite side over adjacent side. So the first one is tangent of the angle A is equal to opposite side over adjacent side. Simple is written as opposite over adjacent. Simple is written as tan A is equal to opposite over adjacent. So tan A is equal to opposite of adjacent, but opposite of the angle A is the side BC. So it's simple is BC of adjacent is the length AB. So tangent A is equal to opposite over adjacent. Opposite is BC and the adjacent is AB. That is the ratio number 1. Next, the ratio number 2 is, if we go back, we have S, which is sine, is either one BC over AC. So BC over AC. So this is sine. So it means sine A is equal to opposite BC over hypotenuse AC. So opposite side over hypotenuse. Simple, we call it opposite over hypotenuse. Opposite over hypotenuse. But opposite of the angle A is still BC, and opposite and the hypotenuse is AC. So it's the same as BC over AC. That is the ratio number 2. And let us finish ratio 3, which is the ratio of cosine of the angle A. So cosine of the angle A, we call it cos A, in the ratio of adjacent side over hypotenuse. But the adjacent of the angle A is the length AB, and the hypotenuse is AC. So this is AB over AC. So these are 3 trigonometrical ratios. Remember that tangent A is simple opposite of adjacent. Sine A is called the opposite of hypotenuse. And the cosine A is called is equal to adjacent over hypotenuse. So it is very, very simple to remember these definitions. So to remember this, to remember the definitions of sine, cosine, and tangent, we can use a simple word. So we can use the abbreviation as so, ga, do, a. So this word is simple or helps to remember the definition of sine, cosine, and tangent. So if we divide this into 3 portions, the first portion, the first 3 letters, so it means S stands for sine, O stands for opposite, and H stands for hypotenuse. The second 3 letters, C stands for cosine, A stands for adjacent, and H stands for hypotenuse. And the last 3, TOA, it means T stands for tangent, O stands for opposite, and A stands for adjacent. So again, sine is the ratio of opposite of hypotenuse, cosine is the ratio of adjacent of hypotenuse, and the final tangent is the ratio of opposite over adjacent. Okay? So this is the trigonometrical ratios. And then from here now, it is very, very simple to use the definitions of the ratio of sine, cosine, and the tangent to work through right angles, triangles. So you can find the value of sine, cosine, and tangent in a given right angle triangles. Okay? So now let us see one example. Let's see one example on how to use trigonometrical ratios to find the value of sine, cosine, and the tangent. Okay, I have one example. In a right angle triangle, let us say our triangle is triangle ABC. And then we have the length of the side AB, the length of the side BC, and the length of the side SC. So AB is 3 centimeter. And BC is 4 centimeter. And the longest one, SC, is equal to 5 centimeter. My equation is find, number 1, cosine of the angle A. Number 1, find cosine of the angle A. Number 2, the sine of the angle A. Number 3, tangent of the angle A. So this is a question, and this question is very, very familiar for those students who are dealing with the trigonometry. And by today, I think make sure that simple you can answer this question. Solution for these questions. It is advisable to draw the right angle triangles and making sure that the longest side represents the hypotenuse of a right angle triangle. So this is our triangle, and make sure that the base here is at B, and the longest is SC, and this is our angles to be considered here. So the length SC is given as 5 centimeter, and the length BC is 4 centimeter, and the final AB is 3 centimeter. Our question is to find cosine of the angle A, sine of the angle A, and the tangent of the angle A. Okay? So now let's go to question number 1. Find the cosine of A. Number 1. Cosine of A is cosine of the angle A, which is opposite adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent of the angle A is 3, and hypotenuse is 5. So simple is 3 over 5. And the number 2 is sine of angle A. Sine A is equal to opposite, simple we write O double P, which represent opposite, over hypotenuse, HYP, represent hypotenuse. So opposite of the angle A is this edge, which is 4 over 5. And lastly, tangent of the angle A, simple tan A, where tangent is the ratio of opposite over adjacent, simply OPP over adjacent. Opposite of the angle A is what? 4. Good. And adjacent is 3. So simple is 4 over 3. So this is how to work out with the problems involving trigonometrical ratio. Okay? So now, before call it the day, let me give one question. I think you can do this question. My questions. Or let's call it exercise. The question is, in triangles, in triangle LMN, in triangle LMN, this is a right angle triangle where LM is 10 centimeter. LM is 10 centimeter. MN is 6 centimeter. And LN is 8 centimeter. Is 8 centimeter. My question is find number one, the tangent of angle M, tan M. Number 2, cosine of the angle M. Number 3, sine of angle M. And the number 4, additional to this, find the value of 2 cos M plus 3 tangent M. So this is a question. This is your questions, and I gave you 2 minutes to answer these questions. So this is the end of the topic. And before calling the day, let me thank you for your listening. My name is Teacher Ame Hajivuai, and I see you next time.